Hello and welcome to the April strategy for talking about analyzing and interpreting data. Now, during the summer, we talked a lot about facilitating discussions around data, and we talked briefly about some of the structures and supports that we can provide to students. But I want to return to some of those and maybe go a little deeper. As we talk about this NGSS practice that overlaps and is really important with many of the other scientific practices, like communicating ideas or constructing an argument or an explanation. So today we want to cover kind of what's the general principle behind helping students analyze and interpret data, and what at the middle school level is developmentally appropriate for helping them make claims about the natural world. So first we're going to look at this kind of overall scheme. You know, there's lots of different types of data. And what data is all around us, and kids are collecting it, whether it's observational data or empirical data, and that's coming into them as raw data. Really important, but ultimately very unhelpful. There's no kind of sense to it, and there's nothing bringing together the ideas about the data. So we want to give students the experiences to gather that raw data, but then really move them toward how do we help them analyze data for pattern making. And when I say analyze, in this sense, I'm going to talk about how do we help them represent the data so that they can then use that summarized version, whether it's in table form or pictorial form or statistical form, to then interpret it to make claims. So what's more helpful is kind of the analyzed data. And what I think is really helpful for middle school students, and you may or may not find this useful, is to focus on, you know, three basic types of data representations, and to do them really well over the course of the year. So each of these three things, tables, graphs, and statistical analysis, are tied to the national standards. But I think they provide students different entry points into thinking about data. So tables are really useful in showing summary ideas, and really pushing students to think about, you know, one piece of evidence is not enough to make a claim. That a table that has this kind of organization and a layout that helps us see sometimes patterns over time, but that it's summarized data. It's data that's collapsed from all these disparate pieces into something that we can kind of take on and then try and interpret. Graphs, of course, are really helpful. They're kind of visual or pictorial representations, and they're especially helpful for English language learners. But they usually, you know, they tell a story. So they help students see that pattern making especially. Sometimes that's more difficult in tables, but with tables at least you can see kind of the raw numbers and make specific comparisons. And then there's statistical analysis. In each case, you know, the use of spreadsheets throughout the middle school year, maybe it's you starting by making the spreadsheet as a class, but getting students to the point where they can make a table and where they can make some basic graphs using Excel is important. And finally, with statistical analysis, I'm not talking about high-level statistics here. I'm talking about mean, median, and ways of looking maybe the range of the data, but some basic data that they can see. Again, we want to take more than one data point. The final thing I'll say is making decisions about the types of graphs. There are so many different kinds of graphs that Excel can make or that students can make, and I think getting really good at two types of graphs in middle school is important. And those would be histograms or bar graphs and XY scatter plots. They serve different purposes, and we'll look at two forms of graphs in a second. But I think if you can get really good at those graphs, you'll be in great shape. And then finally, it can't stop at the representations. The whole point is to interpret the data. And so to use that data and have a structured argument or a written argument that students produce and then talk about. So we had a video a couple months ago about how to help students write an argument. Well, all of the data analysis and interpretation leads up to them developing an explanation and an argument that they can talk about with other students to help form their science ideas. So at the middle school level, I think students should have the opportunity to learn these techniques, as I said, to develop different kinds of graphs, and to talk about outliers. You're not going to talk about it in a statistical sense of, it's 2 standard deviations away from the mean. They're not going to understand that. But to look at pieces of data and question, is that piece of data helpful? Maybe we should keep it in our set because it's good, or should we question, like, was this data actually collected with high fidelity? Was it collected in an acceptable way? And then move students to see that averaging values tends to reduce the effects of measurement error or of some outliers, and helping them explain why these techniques are needed. One strategy I'll leave you with, I talked about briefly this summer, and I wanted to bring it up again, is so students see a picture and there's a lot of data there, and then they get frozen. What do? I don't understand. Provide a heuristic. And the key is we want to provide a template for their thinking so that over time they can release from having to look at a prompt. So I always had a huge poster at the front of the room that had these steps. And we talked about the steps and what they meant and why they're important, but then students could look up and see, if I'm having trouble interpreting a graph, where could I start? And by the end of the year, we took this poster away because they needed to internalize this themselves. So first is like a general, what are we even trying to do? What's the purpose? What could we possibly learn from this graph? Maybe by looking at the title. When students have a context to orient the data to, it makes a lot more sense to them. Otherwise, they might just be looking at a lot of lines and dots. Then we want to break it down into parts. So what does that x-axis represent? What does the y-axis represent? And push students beyond just reading the title. What does that mean? As you move down the axis, what does it mean if it's an increasing number or value, or if it's a bar graph? What do each of those categories represent? And finally, number 4, I think this is the most important one right here. Number 4, what does a single point represent? At this point, students have to basically tie the relationship between the x and y axes together. That at a certain point, this has meaning. And then I can put all these other points together to make ideas about patterns going forward. So let's see what this looks like using that point number 4 especially. So here I have a graph, and you would talk about what it means. And this is showing per capita energy use in 2010 amongst a bunch of countries. And they're comparing based on the tons of oil equivalent, which is a kind of a global measure for energy consumption. So we don't really have to worry about the x and y axes. I'm just using this as an example right now. But how could we use that 4th step? Well, what does 1 point mean? Well, on a bar graph, I say always look at the point at the top of each bar. What does this mean? Well, it means for Norway, we have a pretty high amount of oil use per capita, per person, and or per country. And we don't actually have the labels here, but it's between 0.04 and 0.045. This point right here for the United States, well, they're much lower. It's 0.006. But you can find on any of these categories the single point at the top to help them then make perhaps some patterns. They might group countries together. It's even more helpful with something like this. This is tons of oil used comparing China and the United States from 1965 to about 2010. And there's going to be some great patterns that students can look at over time, that China was much lower, but they have a significantly increasing slope here, that the pattern is increasing over time, whereas the United States kind of peaked and went down and then has slowly come up. Now it looks like it's going down again. But students won't get to that pattern if they don't know what 1 point means. So have them find a point and say, okay, this means that in looks like about 1990, we had about, 7 billion tons of oil. I may be off by a power of 10, but that you could recognize 1 point on the graph. So use this framework, I'm going to go back to it real quick, to help students engage so that they don't get stuck, and then slowly pull that away. Because once they start developing ideas about the patterns, then they can write down a written argument or begin to talk in small groups and use those productive talk moves for making ideas about science that are all around them. Along with this video that's going to be posted on our website are two very brief videos by Jessica that gives just a real quick tutorial that students or you could use on how to make the bar graphs and XY scatter plots using Excel. Because there are many out there, I just list 3 here, that already have existing authentic data, oceans of data. NOAA, they have a whole data in the classroom webpage. There's one on bioinformatics that uses BLAST, a genetic tool, to help students learn about genetics and different traits. And there's many more sites out there that already have existing data, and you may have students collect their own data as part of an investigation. But just keep in mind that raw data is unhelpful. We want to analyze that data by representing it in some simple ways that we help students learn to then interpret to make sense and make ideas about the natural world.